Are we recording? Okay, great. So, assalamu alaikum everyone. Welcome to the 7th tutorial for probability. So this week's tutorial will cover mostly on concepts related to CDS related to uniform variables, and we'll cover exponential distribution as well as uniform distribution. And we're gonna do, so the thing is, these questions might seem a bit easy, but there are a few tips and tricks that people usually miss out on when doing these questions, and that is what the focus of this tutorial will entail. So I'll try to keep this short considering the fact that a lot of you still have mids going on. So I'll try to keep this tutorial within the bracket of like 40 minutes so that we can just get done. Okay, so the first question, I'll give you guys like 10 seconds to read it. So the first question basically says that they've given you an fx, which is k is equals to kx3, kx cube, and they've given you a uniform variable for x and 0. So it should cover all values between -2 and 0. They should not be discrete, they should be continuous. And they're saying find the value of k. Now, essentially what I know for a fact that if you have a PDF and there's a variable that's missing, right? One way that you can use to sort of figure out what that value should be is you can sort of take the integral of the distribution and take the integral, and if that I know for a fact that the integral of a distribution from minus infinity to infinity should be equals to 1. So I'm going to use that property and try my best to sort of find the value of k because of it. So one thing I know is, so in a general case, what a CDF tells you is that when it goes from minus infinity to plus infinity, it gives you of fx, right? It should be equals to 1. And one thing I know for a fact is because they've given me the limits, right, of what x entails. So I know for a fact that -2 to 0 of fx, which is kx cube, should be equals to 1. Now, calculating the integral, I know this is kx to the power 4 divided by 4, and that should be, and when I plug in these limits, -2 to 0, that should be equals to 1. Now, how I can go about this is just inputting the values. I'll let you guys do it if you guys want. So if I input 0, this will be 0. If I if I input -2, -2 to the power 4 is 16, 16 divided by 4 is 4. So minus 4k should be equals to 1. So hence I know for a fact that k is equals to 1 upon 4. No, wait, minus 1 upon 4. Yeah, k is equals to minus 1 upon 4. Now, that was pretty straightforward. I'll go on to part B now. Part B says find the CDF of x. Any ideas on, like, because we now for a fact know that the CDF is known as capital Fx, right? So the CDF of the PDF function that we need to find, and the PDF is k. We know the value of k now, which is minus 1 upon 4. That's minus x cube divided by 4. That's, wait, this is small f. So I'll remove this. This should be small f. Now, the idea when they ask you for a cumulative distribution function of x is that it should cover all possible values of what your initial variable is. In this case, it's x. So it should cover all values of x. So if I have to find the CDF function of this, right, it should be capital Fx. So the last value I have is -2. So any value below -2 should be equals to 0. And any value above the greatest value, which is 0, should be equals to 1, right? That is the rule of a CDF function. And what I have to find now particularly is what sort of this equation should be, and that will be basically for the limits that we've been defined, which is -2 less than equals to x less than equals to 0. Okay, so trying to solve this, any ideas on how, based on the notion I've told you about the CDF function? So in essence, the CDF function basically tells you if I go from minus infinity to any value of x, whether it should be in the limit or outside the limit, any value of x I take, it should be a cumulation of all previous values, starting from the lowest possible value that can be that can happen, which is minus infinity. So minus infinity to x of what fx should be, right? That is what the Cdf function gives you. So in this case, they've given you the limits, right? So what's the last possible value that you can have? That's -2. So -2 to x of fx, which is minus x cube upon 3, x cube upon 4. Yeah, that is what we have to calculate. Now I'm going to integrate this. This will be minus x4 by 16. And I'm going to put in the limits of -2 and x. Yeah. So calculating this, I will get minus x4 upon 16 minus the value of 2 minus 2 power 64, that's minus 16, minus minus plus, this will be +1. So essentially what this value should be is minus x to the power 4 upon 16 plus 1. Okay, so I found the Cdf function of x, and it covers all possible values of small x. Okay, now part C is a bit of a trick. Okay, so the only thing that you have to be careful of in part C is that you have to be careful on what your limits are. Your limits are between -2 till less than 0. So this is fine, but this goes above the limit. So essentially, when I have to find the probability of the Cdf range, right, I essentially have to take care of -1 from -1.5 to 0. Please do not go to 0.5, because it will give you a value of fx, but note your range is only between this range, right? So please make sure you don't make this mistake and that you stay within the limits that's been defined by the function. Okay, because you know for a fact that any value above this will be above 0 will be 1. Okay, the idea is any value above the greatest value, which is 0, its fx value, small fx value, will be 0, right? So between this range, all you have to do is go from -1.5 to 0, and that will be what our function is this, right? So this will be I'm going to take 1 minus 1 upon 4 bahar, go from -1.5 to 0 of x cube, and this will be I have the value written down. I'll let you guys sort of solve this if you want. You can let me know in the chat. Yes, it's 0.3. Great. So the actual answer should be somewhere between 0.3164. Yeah. Are there any confusions? If not, I'll just move to the next question. I'll take that as a no. Okay. So this is question 2. I'll let you guys sort of read it out if you want. So the question has told us that this is an exponential distribution. Okay. So I know, let's see, they've also given me the lambda of the exponential distribution. Okay. So it seems like a straightforward question. So the question says find the proportion of fans which will give at least 10,000 hours. So in terms of notation, what they're saying is at least would imply t greater than a certain t value. In this case, it is, I'm going to erase this. It should be what? 10,000 hours. Yeah. So t greater than a certain value. In this case, it's t is greater than 10,000. So because exponential the general form of an exponential distribution, if it's greater than a certain value, the formula will be this, right? If it's lesser than a certain value, it will be 1 minus this value. Just keep a note of that. Because this is greater than 10,000, this will be minus e to the power. The lambda they've given me is 0.0003, and 10,000 is what we have to calculate. So this will be it. And what I have to essentially calculate is e to the power -3, and that is 0.05 approximately 0.05, right? So I'm done with part 1. Part 2 says if the fan is redesigned so that its lifetime may be modeled by an exponential distribution with lambda 2. So I have a new lambda 2. So okay, so this is a pretty straightforward question. this does not require a lot of thinking per se. So what they're saying is, if I change the lambda, would you expect more or fewer fans to give at least 10,000 hours? The correct way is just to see what the value will be. So minus t e to the power minus 0.0035. The thing is, because it's an exponential distribution, it's a decaying function, right? So because our lambda would increase, I think the value will be low, but I'll just confirm. So 10,000, it will be, let me just calculate it. It's actually, oh, I was wrong. It's that, no, wait. 10,000, right? I was right, yeah. So this value will be 0.03019. Okay, so it's a decaying function, so the value will steep at a faster rate. So for that particular value, this will be low. Okay. Any questions? It was a pretty straightforward question. I'll move on to the next one. The time interval between successive batches between exponential distribution with mean 8 minutes. Okay, so I see what this question is doing. So now I'm gonna ask for some feedback. What do you think our lambda, we know it's an exponential distribution, what do you think will be the lambda value? You can message in the chat. I just want to know what lambda value will we have in this case. So I'm looking at the chat. I'm getting two answers, and okay, so brilliant. So this was the thing I wanted to sort of let you know. The lambda value is a parameter. It's an average. Not an average of what the time you're getting, but it's essentially acting as a parameter for a decaying function. So in an exponential distribution, what lambda is, it's basically lambda is equals to 1 upon your expected value or 1 upon mean, right? It's not the mean value, it is 1 upon mean value. It should be in decimal points. Because I've said mean is 8 minutes, what this implies is your lambda will be 1 upon it, right? That is what one thing I had to sort of clarify in this question. Otherwise, it's a very straightforward question. So now you know the lambda. Keep a note of the fact that a lambda should be in decimals, not a whole number, as you want an exponential function is a decaying function, and otherwise it will just keep going up. Okay. Okay, so that is just one thing I just had to sort of clarify in this question, that just please be careful on what the lambda value should be. Okay, 1 upon the expected value, not the expected value in of itself. So lambda is equals to 1 upon 8. Find the probability that time interval between two successive barges is less than 5 minutes. Okay, so one thing I have to be careful of are the units. They've said the mean is 8 minutes, and what I'm supposed to find is 5 minutes as well. So the mean, the units are fine. I don't have to change anything. So this will be, they said less than 5, right? So this will be, because it's less than 5, it should be, the formula should be this, and minus 1 upon 8 multiplied by 5. That should be, I think, around like 0.46, I'm assuming. Yeah, that's it, 0.46. So I think that's pretty much it. Part B says find the time interval t so that we can be 95% sure that the time interval between two successive barges will be greater than t. Okay, so essentially I have two will be greater than t, right? So essentially what the question is saying, find a value of t such that t any value greater than that specific value should be equals to 0.95, right? I know the formula is e to the power minus 1 upon 8 t, right? So ln on both sides would sort of imply that minus 1 upon 8 t is equals to ln 0.95. Let me calculate the value. So the value of t I'm getting is 0.4103. Are you guys getting this question? Sorry, this answer? If not, please do let me know. Okay, so I'm getting a question says, why do we have to be careful of the minutes? You have to be careful of the units because they can easily trick you and say, find the probability that the time between two successive barges is greater than 1 hour. So the thing is, you might think that lambda is 8 minutes and they say 1 hour, you'll be like, okay, greater than 1, it'll be incorrect. So you have to just be careful of the units. Okay, I guess that's about it. Are there any other questions? If not, I'll move on. So okay, so we're doing uniform variables, uniform distribution now. Okay, so x is uniform and y is a function of x. So essentially, I have to find the expected value of y. It seems pretty straightforward. So it's discrete, right? Discrete in the sense that I have associated value of y is equals to 1, associated value of y is equals to 2. So I know for a fact that I just have to multiply 1 by whatever the probability of it will be and 2 with the probability of what that will be, right? So let me just confirm, how do I find sort of the probability of x less than 3? What's the probability of x less than 3? So x less than 3 would imply I have to find the probability of 0 less than x, x less than 1 upon 3. And the other value would be 1 upon 3 less than x less than 1. Note it's still 1 because x is a uniform distribution from 0 to 1. Hence, from this value to this value, I'm covering the entire sample space of x. So now this will be the general formula for uniform distribution is what? 1 upon b minus a into whatever that x value is, right? So this will be 1 upon 1 minus 0 into whatever x is. So it's essentially x, right? So they're saying less than 1 upon 3. So 1 upon 1 multiplied by 1 upon 3, that's 1 upon 3. 1 upon 3 till 1, that's 2 upon 3. 1 upon 1 multiplied by 2 upon 3, that's 2 upon 3. So essentially, I have to calculate 1 into 1 upon 3 plus 2 into 2 upon 3. This will give me my expected value, which will, I am assuming it will be what? 4 upon 3 plus 1 upon, that's 5 upon 3. Okay, so I'm done with part A. Now, part B basically says I have to find the variance of y. Variance of y basically implies I have to find the expectation of y square minus the expectation of y whole square. So this is basically expectation of y is commuted whole square linear. So that's pretty straightforward. This would imply to calculate this, I have to basically 1 square into 1 upon 3, the probability. Basically, the value of whatever y, the discrete value of y should be squared multiplied by the same probability of what that value should be. Right? 1 square into 1 upon 3 plus 2 square into 2 upon 3. So I'm assuming that's minus by the expectation of whole y whole square. That is minus 5 upon 3 whole square. Okay, this is what the variance of y should be. Very straightforward question. Let me know if there are any confusions related to it. I'll give you guys like 10 seconds. So note how these are very straightforward questions. I think this topic is very good for quizzes because if you know what the questions are supposed to be, you will get done with them very, very quickly. I expect people to do them within like a minute or two. I hope so though. But please do let me know if there's anything that I can help you with and during like before the quiz though, or after the tutorial. Okay, I'm assuming we're at question 5 now, right? We're at question 5. We're again, I'm trying to sort of end this tutorial within 14 minutes, so the pace is going well so far. So the next question is, you arrive at a bus stop at 10 a.m. knowing that the bus will arrive at some time uniformly distributed between 10 to 10:30. What is the probability that you will no longer have to wait more than 10 minutes? Okay, so this is the question where I was talking about before regarding units. We have to be very careful regarding what units we're using because there's a chance that you might make an error because you have to be the values will differ because of it. So because the part A says that you have to wait no longer than 10 minutes, and at the time I can convert it into minutes, it's easier for me if the standard units I use are just minutes. You can convert it into hours, whatever works for you. But for me, I'm more comfortable with minutes. Okay. So what I'm going to say is that it's a uniform distribution that goes from 0, as in 0 minutes for delay, or like the bus time will be 0, and it'll go till, because it's 10 till 10:30, so like 30 minutes. So that is my uniform distribution of it being till 0 till 30 minutes. So the question now basically says, um, find the probability of x being greater than, and that you will have to wait longer than 8 minutes, so more than 10. So x is greater than 10. So knowing the formula of uniform distribution as b of minus a into whatever that value of x is, it will be 1 upon 30 minus 0, that's 1 upon 30. So this is what I have to multiply with everything. Because it says x greater than 10 and the maximum value is 30, so the possible values that are in between all of this are 20. So this will be multiplied by 20. So this value should be 2 upon 3. Okay. Now for part B, they're saying if at 10:15 the bus has not yet arrived, what is the probability you have to wait at least additional 10 minutes? So this is where conditional probability comes into place. So what they're saying is, find the probability that you wait at least an additional 10 minutes, and you've already waited for 10 minutes. So I think what they're saying is, conditioned on the fact that it's been delayed for already 15 minutes, because you have to see if it goes for more than 10 minutes, right? What you will have to see now if it goes till 25, because what they're saying is it will go till like more than additional 10 minutes. Everything okay? Fazan, do you have a question? Okay, I'll take that as a no. So greater than 25, given that it's greater than 15, because we have to make account of the fact it's additional for more than 10 minutes. So 15 plus 10, 25. Okay. Knowing Bayes principle in conditional probability, I'll make a diagram of this later on as well. So essentially expanding this will be x greater than 25 and x is greater than 15 upon probability of x greater than 15. Now, can anyone tell me what this numerator implies in terms of what this value can be simplified as? I know it goes till 0 till 30, right? बीच में यहाँ 15 आ रहा है और यहाँ पे 25 आ रहा है, right? So what are the ranges of values that are greater than 25, which is this, and it's greater than 15? It's essentially greater than 25, right? Because the question says it. So using Bayes, it's also called Bayes probability, Bayes theorem, but at the same time, I'm more comfortable in using this as logic, right? If it's greater than 25 and it's greater than 15, it basically implies that it's greater than 25, right? Because it's an AND statement. So this will be p is greater than 25 upon p is x is greater than 15. So this will be, I calculate, okay, so x is greater than 25 would basically imply 1 upon 30 multiplied by 5, because 25 to 35 values, 5 upon 30 upon 15 upon 30. So this will be 1 upon 3. Okay, are there any confusions? Can you elaborate on what x is greater than 25? And okay, so the question that I've been asked is, why can we assume so? So the thing is, this is very specific to this question. It's not a rule per se of uniform distribution, but because the question has been structured in this way, I can say that if x is greater than 25 and x is greater than 15, but in terms of words, what implies is, अगर मुझे पता है कि आपको what's the probability of you waiting greater than 15 minutes and you waiting greater than 25 minutes? It's essentially the only intersection point between these two conditions is just this range. I mean, और कोई values तो नहीं आएंगी ना. Essentially it's a it's a subset, right? This is 25 and this is 15, and you basically have to find the intersection of both, and in this case it's the entirety of x is greater than 25. This is not the memoryless property, because the memoryless property only applies to exponential distributions. Please keep a note of that. Exponential distribution only applies to the memoryless property only applies to exponential distribution. This does not apply in this case. This is just because the question has been structured in this way, we're going to use this approach. Okay, so hence why I can just write it in this way. We'll do is the last question. The last question will sort of compare exponential and uniform distribution. That will be the last question, because we're already done with 5 questions. The last question will be done very quickly. Okay. But any questions on this, please do let me know. Is there any other method that we could? I am not aware of any other method that we could have done to do this, because you have to, because uniform distributions आपको probabilities तो जरूर मिल रही हैं, लेकिन the question is essentially conditional probability, and I don't think you can expand this in another way apart from conditional probability in this way. So I'm assuming this is the only method, but please do let me know, or anyone else can let me know if there's another way. I think this is the only way to do it. Okay, so I'll move on to the next question. So we're doing the last question now. I'll give you guys like, it's a long question. I'll give you guys 20 seconds to read it. Okay, so I'll go over the question again. Jones figures that the total number of thousands of miles an auto can be driven would be chunked as an exponential random variable with parameter 1 upon 20. So I know this is the parameter and it's an exponential random variable. He claims has been driven only 10,000 miles. If Joan purchases a car, what is the probability that she? Okay, so this is a similar case to what we did before. It's exponential. Instead of it being uniform, it's exponential, but it's still using conditional probability. So what they're saying essentially is, okay, I have to be very careful of the units that I saw above, because of the total number of thousands of miles. It's not like my units will be 30,000. It will be 30, because the question says figures that the total number of thousands of miles that an auto can be driven before it needs to be junked is in random way with parameter 1 upon 20. The parameter has been set in such a way that it deals it in thousands of miles. If I do it with 10,000 to 20,000, my answer will be incorrect. Okay, or it won't make sense if you think about it intuitively, right? So I have to be very careful in terms of the units here as well, because the parameter has been defined already. So knowing the file, it's in 10,000s of miles, given that it's been driven only 10,000 miles, which implies given that it's only been 10 greater driven only. Okay, so this is what they're saying. This is the given condition, and now they're saying additional 10,000 miles. Additional 10,000, 20,000 miles would imply 20,000 plus 10,000, that's 30,000. So x is greater than 30, right? Now this is where the memoryless property of exponential variables can come to our advantage. So this would imply that this can be written as x is greater than basically 30 minus 10. The difference is 20, right? So what we have to figure out right now is px is greater than 20, and I've been given the parameter because it's greater than it, right? So it's minus 1 upon 20 into 20, that is e to the power minus 1. Okay, note, if you had not keeping account of the units, you would have written it as 20,000 and you would have gotten it wrong. So please be careful of the units. I can't stress it enough. A lot of people have struggled on the units previously before as well. Any questions on this? Where has it been? So the thing is, the first statement, the question that's being asked is, where has it been written that we have to keep a note of the units, because we could also written it as 10,000. The thing is, the first statement basically implies that the number of thousands of miles that's been used, uska parameter 1/20 है. Had you picked your parameter, yeah, they had given you other information in which you had to pick your parameter, तब आप ये जरूर कर सकते थे कि you would have written it as 20,000 or 10,000, whatever works. But in this case, because they have already stated that the total number is between thousands of miles or uska parameter is 1/20, we have to be very specific in not using 20,000, we just have to use 30 or 10. Okay. I hope this answered the question. If not, please do let me know after the tutorial. So I think we're done with part A. Repeat the assumption that the mileage of the car is not exponentially distributed, but rather uniformly distributed over 0 to 50. No, they've also stated that the units will remain the same. So I'm going to quickly do part B because I think this is the last question and then we'll be done with the tutorial. So part B basically says we have to do the exact same thing, but in uniform distribution. So in uniform distribution, I cannot use the memoryless property, but let's see how things work out. X is greater than 30 given X is greater than 10, right? Is the same thing. So I'm going to expand this, P X is greater than 30 and X is greater than 10. Now let's see what this statement applies. अच्छा पहले लिख दूं P X is greater than 10. Now what they're saying is अच्छा X variable बता क्या रहा है कि the total number of thousands of miles that an auto can be driven. So can I say that if a car has been driven for more than 10,000 miles and the car has been driven more than 20,000 then more than 30,000 miles, I'm assuming. Yeah, this is 30,000, right? Okay. What should can I simplify this equation as? Likewise, in the previous part, the only intersection point between these two statements is this, right? This bit does not apply because it's not greater than 30. So I can write the numerator as Px is greater than 30. And I can also see there's a difference between what the term with the memoryless property and exponential random variables got simplified as in this case and what it's now been simplified as. Please note, again, memoryless property only applies to exponential random variables. Do not think that this is memoryless. This is not memoryless. It only applies to exponential random variables. So solving this, our range is from uniformly distributed between 0 to 40, right? So 30 से 40 के दरमियान there is what, 10 points. So 10 divided by 40 minus 0, that's 40. 10 upon 40 upon greater than 10, so that's like 30 points. So 30 divided by 40, so that is 1/3. Let me just confirm and see. Okay, so this is 0.33. What's e to the power minus 1? 0.367, and this was 0.33. The thing is, I think what this question also wants to show to you is the fact that because you're already given a parameter, you're already given sort of an edge. It sort of says that an exponential random variable might be a better approximation for this sort of problem statement or this sort of model. It all depends on the parameter. Had we used a wrong model or the wrong units, like I've mentioned 1,000 times already, we would have gotten an inaccurate answer. So the exponential variable distribution can give you a more accurate answer, but it solely depends on the parameter that you're using. The parameter has to be very accurate. Otherwise, you can always use a uniform distribution. Okay, so I think that's pretty much it. If there are any questions, please do let me know. If not, I will stay in the tutorial. I will end the recording and still post the tutorial. And if you want me to answer any questions, I can. If you want any information on how to go about the prep for the quiz, please do let me know. I will be ending the recording right now.